Hey guys, advent of code day 3 in Kotlin scripting language. So in this question, we get given a list of numbers, and then for each number we want to say in part 1, if you can only take 2 digits from this number, what's the biggest number you can make essentially, and then add the result of all of those. So yeah, as you can probably intuition, it's some sort of greedy algorithm where you just take the 2 biggest numbers, but the index of the first number has to be greater than the index of the second number. So in this case, we can use some greedy solution where we try and get the biggest possible value for the first number because that will maximize our result. And then we take, after we get the biggest possible value, we just take the next greatest value after that as a second digit. Some sort of intuition here, so I started, and this is explaining my code as well. We first start with this left digit here as the first position, so left digit would be here. And then what we do is we go through the rest of the string and we check, okay, here, say we're at this position now, let's save this new value as 81, that's our new best, and then we check, is this 81 better than our new best? So that's our first, so we keep it. And then we'll move to 7 here, we say, is this 87 greater than our best? Yes it is, so we keep it. Move on to 8 here, is this 8 greater than our best? 88, yes, so we keep it. And this index is moving over here now. And then we get to 9 and we say, is 9 better than our new best? Yes, we got 89. But now since 9 is greater than 8, we want to make this our leading digit because greedily we want to have the biggest number be first. So then we'd move our leading digit from 8 here to 9, and then we'd say 9 is our leading digit now, and we go to 1, and this would be 91, which is our new leading digit. So yeah, that's pretty much what I've done here in this one for loop. Get it done in O event time, luckily. Part 2, now instead of taking the 2 biggest digits, the 2 biggest, we want to take the 12. So we want to make the biggest possible number, taking 12 digits from these numbers now. And you can see my code for that here. Essentially what I did in this instance is I greedily I took the indexes of the first 12 elements, so say they're these numbers here, and then we're starting with this element here, and you can see that's what I've done here. So I've taken the indices of the last 12 elements, and then I've said essentially say that this is the first element. I'm going to greedily start at the back and then try and select the further leftmost element that is greater than this. So this would compare to 5. Is this bigger? Yes. And then we'd move this index back to, we'd move the first digit's index back one. And we keep bumping it back. So then essentially we can see we have this for loop here, and we have this front cutoff. And what this does is saying, as we're checking, so say for the second number, we want to make sure it doesn't go past the first digit number. Because like say we've made the first digit a 9, we can't have the second digit also be a 9. It has to be a number in front of that 9. So essentially the range it can be is like limited. Yeah, say for this number here, if we've already used a 9 before, then we can only select values in between this range here. So yeah, looking through the code, we take the last 12 indexes and we say for each of these indexes we get the value and we have a best, and essentially if it's better than the best, and starting and going backwards. And we actually have to go backwards because in this test case we greedily want to get the leftmost value that has the biggest value, and that's because the leftmost value, so say there's 3 8s and I'm at this position here and I want to replace this, say I'm at this position here and I want to replace this, we want to get the leftmost so that if we take this one then we can still use these two in the future. Whereas if we take this one, now we can't get any value further left than that, so later on with this like 1, it'll try and look for 8, but there's nothing left because they're all taken. That's pretty much it. So